So we just took a look at what happens when an MDI type of device wants to communicate with an MDI-X type of device. And again, in most cases, this is going to be a switch on one side and a non-switch on another, maybe a PC or a router. At this point, we are going to use that straight through cable that we mentioned. A straight through cable, just like the name implies, straight through, is going to connect pin 1 to pin 1 all the way down to connecting pin 8 to pin 8. However, what happens if we change this up? What happens if we have a situation where now I've got an MDI-X device over here, let's say it's another switch, and I want to connect this MDI-X device to another MDI-X device? Well, now we have a problem because they're both trying to follow a set of rules that allows for compatibility with an MDI type of device. Remember, an MDI is transmitting on pair 1-2, receiving on 3-6. And so this MDI-X device is saying, okay, I'm going to try to flip that around. I'm going to follow the MDI-X set of rules, which means I'm going to receive on 1 and 2 and transmit on 3 and 6. The problem is now I'm doing that on all of my interfaces. And so I turn around, I do that facing this other MDI-X device, and guess what? It's following the exact same rules. I'm trying to receive on the same pair, I'm trying to transmit on the same pair, and this is going to cause massive problems. Now, this is going to cause problems when it's an MDI-X and an MDI-X, but I could also do the same thing over here and connect an MDI device to an MDI device. Maybe these are two PCs and we're just trying to directly connect the PCs, or by the way, in a lab, maybe especially, we might have a router and I'm trying to connect those routers together. So I grab a straight through Ethernet cable and I plug in the two routers and nothing comes up. There's a good reason for that, and that's because we've now broken our paradigm, which was we're going to follow a different set of rules and use a straight through cable. Well, now we're following the same rules, and we're following the same rules. We cannot use a straight through connector. This is where we need a new type of cable. Rather than a straight through cable, we are going to use what's known as a crossover cable. A crossover cable is designed for this exact situation. What we want to do is we want to enable communication between devices that are following the same sets of rules. So how are we going to do that? Well, we're no longer going to be able to connect one pin to the exact same pin on the other side. We're going to have to flip these around a little bit. So basically, we're going to sort of cross the streams up here and make it so even though I'm transmitting on 3 and 6, it's received on 1 and 2. And even though I'm receiving on 1 and 2 here, I guess it's the other way around. Even though I'm receiving on 1 and 2, it's going to receive what was transmitted on 3 and 6 on the other side. And we're going to do that in the cable itself. Now, the way we're going to do that, we're going to take a look at here in a few moments, but essentially, we're going to swap the pin out. So 1 and 2, 3 and 6, like we said, normally we just connect these straight up, 1, 2, 3, 6, and we just connect them straight across. That would be a straight through cable. Instead, we're going to have to connect 1 to 3 and 2 to 6, and then 3 to 1 and 6 to 2 in this fashion. And again, we'll see the details here coming up. Now, we mentioned something also that's worth going into a little bit more detail, which is the concept of Auto-MDIX. Auto-MDIX is a feature that is going to detect when we're using the wrong cable. Since it can detect the use of the wrong cable, it's going to then change the rules that it's following. So basically what could happen here is I've got a switch, I have a switch, and I'm connecting those two switches, and I have a straight through cable. If one of these switches is running Auto-MDIX, let's say the switch on the right is running Auto-MDIX, it's going to realize that, hey, you're transmitting on these pairs that I'm trying to transmit on, so I'm going to flip around. And instead of following MDI-X rules like I'm supposed to, I'm going to switch over and follow MDI rules on this interface. And that is thanks to this feature called Auto-MDIX. Now, the good news is that in our modern era, there's massive widespread support for this feature. We see this on most modern switches, most modern PCs, modern routers, and as a result, the need to carry crossover cables with us has actually gone down over time. It used to be that I had to use a crossover cable to connect two switches like this. But because Auto-MDIX is so prolific, meaning it's just out there everywhere, I can pretty much just carry straight through cables with me, and when I connect two switches together, it'll automatically flip the pairs. But at the same time, we as network engineers need to understand what exactly Auto-MDIX is doing, why it's so important, and we need to come back to understanding the difference between an MDI device, MDI-X device, and really what's happening under the hood that requires some amount of intelligence when we do connect similar devices. Thanks for watching. Be sure to click here to subscribe to CBT Nuggets and click the notification bell to make sure that you're aware of every time we post new content. If you're interested in a career in IT or you want to brush up on your IT skills, then swing over to our website, and while you're there, be sure to sign up for a free trial.